Bright Tuty. Every student matters.
Hello students, let us continue the chapter mensuration. Now what we are going to do and what we have done. We have done areas of polygons and quadrilaterals, special quadrilaterals like rhombus, parallelogram, areas of triangles. This is all what we have done. Now we will move to solid shapes. Like 3D shapes we will move to, and one by one we are going to learn about all the shapes, right, that are in your syllabus, and we will find the areas of them, right? Okay, so if you see here, there are some solid shapes. Like the first one is a cuboid, the second is a cylinder, this is a cone, this is a cube having all the edges as equal, and this is the pyramid. Right, so these are what? Solid shapes. So out of these we are going to discuss cuboid, cylinder and cube. These three we are going to discuss in detail, how to find their surface areas and how to find out their volume in the next lecture. Okay, so in this lecture we are concerned about finding the areas of cuboid, cylinder, cubes, surface areas. Okay, now if you see here, there is a cuboidal block, right, or I say a box. So the faces are shown by separating each other. Just see, this is the top face, this is the bottom face, so two faces, and this is the side faces. These are side faces. This is front and back and left and right. Right, so the four side faces we have, two, one on top and one at the bottom we have. So they are saying all six faces are rectangular and opposite faces are identical. Yes, opposite faces are identical. How? Top and bottom are same and exactly same. The side faces, opposite faces are exactly same. Okay, so there are three pairs of identical faces. Yes, top and bottom is the one pair, front and back is the second pair, and left and right is the another pair. So we have total six faces, right? Okay, if you see in the cube we will have all the six faces as identical, because in cube we have all the dimensions as equal, whether it is length, breadth and height. So here all the six faces are going to be of same measurement, they are same, so they are squares. Okay, so how many squares? 6 squares we have. Now, if we talk of the cylinder, we have one circular face at the top and at the bottom, and one curved face, right? This circular part is known as the curved face. This one, as shown here, this one is the curved face. Okay, so this is the curved face, and these are the plane surfaces we call, and circular base we call them. Circular base and circular top we have in the cylinder. So how many? Three faces we have, two circular faces, the base faces, and one curved, right? So one curved face and two circular faces which are identical. The circular faces you can see are identical to each other. Okay, so we have learnt about three. First we discussed about the cuboidal, then we discussed about the cubical block, and then the cylindrical box. Okay, now this is a right circular cylinder. How? When we know that the line or the center of the top part, right, that is the top surface, top circular face. Okay, the center of that, when we join it to the center of the bottom, or I say the base surface, okay, base circular face, and we join them, they make 90 degree with the radius, right? They form 90 degree. So these kind of cylinders are known as right circular cylinder. So in your class or in our session, we are going to study about right circular cylinder only. So this is what is called as height of the cylinder. This is called as the radius of the cylinder. Okay, and the radius are going to be same because they are identical. The circular faces are identical. Okay, now if you see here, why is it incorrect to call the solid here a cylinder? A cylinder has the top and the base surface as identical. So is this face and this face identical? No, it has a greater radius and its radius is smaller. right? If we join them, the radius is smaller, so they are not identical, so it is incorrect to say this solid as a cylinder. Actually, when you will go to higher classes, you will learn about this, and this is known as frustum. You will learn about frustum in detail later on. Okay, now here we are going to learn about surface areas of cube, cuboid and cylinder. So what about the surface area of cube, cuboid and cylinder? If we talk of, there will be two terms. One will be total surface area, one will be lateral or curved surface areas, right? So we have two terms, that is total surface area. When it is not mentioned in the question, we are going to take total surface area, and if it is curved or lateral, then it would be mentioned or some conditions would be given to us. Or we have lateral in case of cube and cuboid, right? And curved in case of cylinder we have. Right, so what are these kind of areas? What is the difference between these two terms, and how to find out total surface area and lateral surface area? So of these three figures we are going to learn. The first one is a cuboid, the second is a cube, and the third is a cylinder. So these three we are going to learn about. Okay, just see here now. We are going to first do it for cuboid. In cuboid, if you open this box, right, here is written paste. So what are they asking? Just open them and then paste it again. So we can see the net of a cuboid. Okay, and we see the top and bottom. The first, the second and sixth, they are the top and bottom. These are the side faces. So how many total faces are shown? 6 faces are shown. Now, what will be the surface area of this net that is drawn here? That will give us the surface area of this cuboidal block. Okay, so how many faces? 6 faces. So we will find out area of each face and we will add them. Okay, we see each of them is a rectangle. Now for the first face, if I see, what will be the area? Just see, L into H. So LH is the area. What about the second part, that is L into B, right? So it is LB. Now here the third one, what will be the area? It is B, and the standing one is height, it is H. So it is BH. Now the next one is LH, the next one is BH, and this one is LB. So if we add all, just to see, LB plus LB is 2LB plus BH plus BH is 2BH plus 2 times of LH plus LH, or HL we say, right? So this is the total surface area. So we write it as TSA, that shows total surface area of cylinder, cuboid we have. Okay, of the cuboid is 2 times length into breadth plus breadth into height plus height into length. This is the total surface area of the cuboid. Right, this is how we are going to find out when we talk of total surface area of the cuboid. Okay, now if I have to talk of the lateral surface area, right? Lateral means the side faces only we have to take. Top and bottom we are going to exclude from them. So when we talk of lateral surface area, that means sideward surface area. So we are going to take the side faces only, the 4 walls only. Suppose you are sitting in a room, right? Just remove the just leave the roof and the floor, and the 4 walls that are known as the lateral surface area of that room. That means area of 4 walls. We mostly call it as area of 4 walls. So area of 4 walls we say, or we say lateral surface area of cuboid, lateral surface area. So what we are going to do in that? We are going to just take these 4 faces. So for the 4 faces we have 2 times LH and 2 times BH. So when we take common 2 and H, we get B plus L. So 2 length plus breadth into height. This is the lateral surface area. This is the total surface area. So you need to remember these 2 formulas for cuboid, where it is shown what is total surface area, what is lateral surface area. So whenever we are asked to calculate the total surface area, we will use the formula 2 into LB plus BH plus HL. L is the length, B is the breadth, H is the height. Okay, and if we have to just find the area of four walls or just find out the lateral surface area of the cuboid, the formula is 2 multiplied with height multiplied with the summation of length and breadth. Clear? So these are the two formulas you will remember. Now next, here we have to apply this formula. So we have to find the total surface area of the following cuboid. So we are given two cuboids. In the first one, we see the length is 6 centimeter, the breadth is 4 centimeter, and the height is 2 centimeter. We know total surface area, we write in short as TSA, total surface area will be equal to 2 into LB plus BH plus HL. So 2 into what is the length? 6 into breadth is 4 plus 4 into height is how much? 2 plus how much h is given to us? 2 into what we have then? We have L. L is 6. Right? So let us solve it. 2 into, now the unit is centimeter. So the area will be in square centimeter. 2 into 6 fours are 24 plus 4 twos are 8 plus 2 sixes are 12. Square centimeter. We get 2 into, just say 12 plus 8 is 20, 20 plus 24 is 44 square centimeter. So the total surface area is 88 square centimeter. Clear? So this is how we find out and apply the formula to the questions like this. Now I think for the second one you all can try independently. We are given length as 4, we are given breadth as 4, and we are given height as 10, and all are in centimeters. So the total surface area will be 2 into. So the same formula we will use. What is length given? 4. What is breadth given? 4 plus breadth is 4. Height is how much? 10 plus 10 into length, that is 4. Square centimeter will be the unit. So 2 into 4 fours are 16, 4 tens are 40, and 4 tens are 40. So we have 40 plus 40 as 80, 80 plus 16, 96. 2 into 96 square centimeter, 2 6 are 12, 2 9s are 18, and 119 square centimeter. So 192 square centimeter is the area for the, or we say the total surface area for the second cuboidal block that is given to us. Right? So we have calculated the total surface area of these cuboids. Now here there is a formula shown for the lateral surface area of the cuboid, that I told you that it is 2 into height into L plus B, that is the sum of length and breadth. So the top and bottom, this we are not going to count. Okay. Now the next one, here is one other question. They're asking you, can we say that the total surface area of the cuboid is lateral surface area plus 2 into area of base? Yes, we can definitely say it. Just see, if we find the area of 4 walls, you have the area of 4 walls, now you are adding the area of the base. You know your floor and the ceiling part, okay, the roof will have the same area. Right, and between them the 4 walls are there. So yes, we can say that area of 4 walls, or the say lateral surface area. What is lateral surface area? 2 into H L plus B, and area of base will be 2 LB. Right, and from here to LH to BH plus 2 LB, and this is total surface area. Right, so yes, we can say that total surface area of the cuboid can be written as lateral surface area plus 2 times area of the base. Right, why 2 times? Because of the roof and the bottom we are looking on. Now they are saying, if we interchange the length of the base and the height of the cuboid, what we are doing? We are interchanging the length and height. So to get another cuboid, will its surface, lateral surface area change? So what we are doing, just instead of this L, right, we have interchanged it. L and H are interchanged. Instead of L we have H, and instead of H we have L. Right, so the cuboid will be formed like this. Okay, so they are saying, will the lateral surface area change? The lateral surface area is 2H into L plus B. Now instead of H we are going to write L, and instead of L we are going to write H. We are going to interchange them. So we get 2LH plus 2BH. So is this 2LH, and here we were having 2LH plus 2BH. So is it changing? Does it get changed? Just look carefully. We have the surface area as 2H into L plus B, the lateral surface area, which gives us 2LH plus 2HB. That means BH. And here also when we exchange them, when we interchange them, right? So are we getting the same formula? Instead of L plus B, we are writing H plus L. So area of the four walls in total will be same, right? Whether you make it stand or you make it lie horizontally on the plane surface. So yes, we get the same lateral surface. Here also 2LH is there, 2LH is there, 2BH is there, 2BH is there. Yes, so it doesn't get changed, right, after exchanging height and length. Okay, now move to the next part. It is a cube now. So we know in cube the dimensions are going to be same. The length, breadth and height all are same. So here if I have to find these, now we know these are square. So area will be L square, L square, L square, L square, L square and L square. For all the 6 faces, if we add them, the total surface area of cube will become as L square, 6 times L squares we have. So 6 times L square, this is the total surface area. And what is the lateral surface area of the cube? It will be just, see, we don't have to include this and this, right? So we have 4 times L square. Right, so these are the formulas for the total surface area and lateral surface area of the cube, where we have the 6 faces. All of them have the same dimensions. They are squares actually. So 6 times of L square, where L is the length of the edge given to us, is the total surface area, and the lateral surface area is 4L square, because we are not going to count the top and bottom in the lateral surface area. Okay, now moving ahead, we see here a question. So they're asking, find the surface area of a cube and lateral surface area of cube B. So surface area of this cube, then it is not mentioned, so total surface area we are going to find, and here we have to find the lateral surface area. Okay, so total surface area is 6L square and L is given as 10. So square of 10 is 100. So 6 into 100 gives us 600 square centimeter is the unit of area. Clear? Now of this, if we find out, it will be 4L square. So 4 into L square, that is 8 square. 4 into 64. 4 4s are 16. 4 6 are 24 and 5 26 square centimeter. So this is the lateral surface area and this is the total surface area of different cubes that are given to us. Okay, now here is another thing that you need to notice. Just to see, they are saying 2 cubes with each side B. This is the first cube, this is the second cube, and the side or the length of the edge is B in both of them, right? And they are saying are joined to form a cuboid. They are joined like this. Here we have joined them and it is forming a cuboid now. What is the surface area of the cuboid? Right? Is it 12B square? Then they are saying what is the surface area of the cuboid formed by joining such 3 cubes. So for 2 cubes, if we see, what is the one side that is becoming, it is 2B, and another dimension is B, and one more dimension is B. For this one I have written, right? What will be the total surface area of this cuboid? The total surface area will be 2 into LB plus BH plus HL. So 2 into what is length? 2B into breadth is B plus breadth is B, height is also B, plus H is how much? B, and the length is 2B. So we get 2 into 2B square plus B square plus 2B square. So how many? 2 and 2 4 and 1 5, right? 5 into 2 is 10B square. Correct? So we are getting 10B square. So they are asking, is it 12B square? No. The answer is no. It is 10B square. Clear? Now they are saying what is the area of the cuboid formed when we join 3 cubes like this. So just the length will become B plus B plus B 3B. Height and breadth will remain same. So if we calculate it, we will write 2 into 3B into B plus B into B plus B into 3B. Right? So we get 3B square plus B square plus 3b square. So we get 3 and 3, 6 and 1 7, so 2 into 7b square, so we get 14b square. So is it 18b square? No, it's not 18b square, it is 14b square. They're asking the reason. These are the reasons that we have given, you just need to show them by solving. Clear? So this is how we are going to verify the answers. So by joining them, only the length changes, right? The breadth and the height are same. In case we keep one above the other, then the height will change, length and breadth will remain same, but they are placed horizontally adjacent to each other. Okay, now moving ahead, here is a question, okay, and you need to be very careful in looking on it. They are saying, after the surface area of a cube is painted, that means all over this cube is painted, okay, from all the sides, all the 6 faces are painted, suppose with any color. Now they are saying it is cut into 64 smaller cubes of same dimension. So we see there are 1 2 3 4, so 16 here. Okay, so we have cut out 64 smaller cubes of same dimension. So 64 cubes, if we have 64 cubes we have, that means the length, breadth and height we know are same. So it is going to be 4 into 4 into 4. This is the triplet that forms 64. So we have found out that the dimension is going to be 4 4 4. They are asking us how many have no faces painted. We have to find out the number of cubes. How many have no face painted, 1 face painted, 2 face painted and 3 face painted. Can we have more than 3 face painted? Just think about it. We cannot have. The maximum painted faces will be 3. You know, when you paint, this is suppose 1, this is the second and this is the third. 3 faces most probably will be painted, right? We cannot paint by breaking it, right? Just be sidewards painting is done. Now they are asking first one, no face painted. The faces where no face is painted. So let us first start with 3. Okay, 3 faces painted. So of the corner one, we see that 3 faces are painted. 1, then this one is there, this one is there, and beside it, it is 1 face. So the corner, if you see, you take a cube in your hand, right? The playing cube that come, that so the dice that we get from the market. So when you see the corner ones, right? So there are how many? 8 corners. So the corner faces, all the corner cubes, there all the 3 faces would be painted. So how many, what is the answer for 3 faces painted? It is 8 cubes. Now let us go to 2 faces. Okay, 2 faces means just 2 faces are painted. So if I see this one, okay, let me just make a different color. So this one, this is the cube whose these 2 faces would be painted. This is the cube whose 2 faces would be painted. Similarly, this is the cube whose 2 faces would be painted. So like this, these are 4. So similarly, we will have this one, right, on this face, these 2. So we have 2, 4, 6, and then we will have this one and this one. The bottom is also faced, right? So these are just 2. So we have here also, this is 1, then this is 2. So just see, are you looking on this? So what we are going to do is just see, count them. 1, 2, right? Then 3, we have, okay, 1, 2, 3, 4. Okay, we name them with a different color so that it is visible to you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now of this face that is behind it, this is already counted. So we will have 1 more at bottom, right? 2 more at bottom. So 11 and 12. And on this face, if we see, just see, it will be 13, 14 and 2 at the bottom. That is 13, 14, 15, 16 we will have, right? Now talking about the bottom face. So these 2 are included, and from that side also the 2 are included. So these 2 are included, right? And what about the below one? Those are also included in 3 and 4. So total how many do we have? 16 we have whose 2 faces are painted. Now 1 face painted. Okay, now we have to answer 1 face painted. So just see this one, when we paint 1, 2, 3, and 4. These are the 4. In between the 4 squares, you can say, are there, which are just 4 faces painted, but only one of the face of those cube is painted, right? So these are 4 here. Okay, now similarly here 1, 2, 3 and 4. These 4 will be there. So 4 is this one, 4 is this one. So every face we will have 4, right? So how much we will have then? 24. 4 6 are 24. So we have 24 number of cubes whose only one face is painted. Now comes no face painted, right? So no face painted is just to see of the all the 6 faces they are painted. So the cubes are there. Now top and bottom, just leave those layers. Talk about 2 between layers, the cubes that are inside this, right? There are 2 like 4 cubes on one and 4 cubes on the second one. You get that? So how many we will have that? So when we talk of no face painted, we will have 4 inside it, right? 4 of the second layer, 4 of the third layer. So there will be 8 whose no face will be pointed because they are inside the cube, right? They are not outside, that after painting outside they will be painted. They are inside, they are lying inside. So yes, the top and bottom surfaces or the faces, their cubes will be painted from one side, 2 side, 3 side, but the between 2 layers, the second layer and third layer, if I name this as L2 and L3, these are the second and third layer. For these, if we talk about, there are inside 4 and 4 for 2 of them. So those are not painted, so they are 8. Is that clear? So this can be more clear if we have this in practical, right? We can view it, we can rotate it, see which of the faces are painted, not painted. So that is actually a work of the lab that you can do. In your maths lab you can do it. You will definitely find a cube, or you can just purchase, this is known as Rubik's cube. So you can purchase it and you can perform it. It is going to give you more appropriate answers. Also, you will be able to count it easily. Now to imagine it is difficult. So it's just an activity that you can perform at your home, and you will get different number of faces painted for different faces painted like 1, 2 and 3. Okay, so here is the cylinder. Let us talk of cylinder. So we have discussed cube and cuboid. Now we are going to discuss about cylinders. So this is the cylinder, we know. Okay, so what we are doing is we are cutting it from here. Right, from this part we are cutting it. So when we open this circular opening, okay, and we get a rectangle. This is a rectangle, if you see, right, and this is because the height, so the width will become the h, that means height of this rectangle. And because on the top there is a circle formed, when you open that circle, that becomes the circumference, right? So this is 2 pi r written here. Okay, so 2 pi r into h. If I talk of the area of this rectangle, that means this is the curved part only. So when we talk of only the curved surface area, the length into breadth, that is 2 pi r into h. So it is 2 pi rh. Okay, when we talk about curved surface area or lateral surface area of the cylinder, it is 2 pi rh, and the reason you can see here. You can just perform this activity. Okay, now what is the area, the total surface area? So we have to add the area of both the top and bottom, or the base and this rectangle or the curved surface also. So pi r square plus 2 pi rh. So 2 pi r square plus 2 pi rh. We can take 2 pi r common, we get r plus h in the bracket. So this is the total surface area formula. This is the curved surface area formula. Is that clear? So the face is curved, that's why we call it as curved surface area, and it is by excluding the top and base. When we include the top and base also, it is total surface area. So we will apply these formulas. You need to remember them. Okay, so here you see one question. We have to find the total surface area of both the cylinders. In the first one we see r is given as 14 and height is given as 8. So r is 14 centimeter, height is 8 centimeter, and we know total surface area is given as 2 pi r into r plus h. Whenever it is not given in the question, we will take pi as 22 upon 7 always, right? Unless it is stated take pi as 22 upon 7. In case they would want us to take 3.14, they'll mention it in the question. Now we will write 2 into 22 upon 7 into r. R is how much? 14. So 14 plus 8. Just see 7 2s are 14. We get 2 into 2 is 4. 4 into 22 is, just see, 88. Into 14 plus 8 is 22. We can multiply these two. Yes, 88 and 22, multiply them. 2 8s are 16. 2 8s are 16 and 1 17. So like this we will get 6, 7 and 6 3, 13 and 1 will be the carry, 7 and 1 8 and 1 9. So we get 1936 square centimeter as the area. Okay, what about the second one? We are given the radius as how much? Just see, this complete is given as 2. This is the diameter, right? So if the radius will be 1 meter, that is half of the diameter, and height is given as 2 meter. So total surface area will be 2 pi r into r plus h. So 2 into 22 upon 7 into r is 1. 1 plus 2. So we get 2 into 22 upon 7 into 3. Right? So we can just solve it. 3 2s are 6. 6 into 22. 6 2s are 12. 6 2s are 12 and 1 3. 13. 13 upon 7. So this is the unit is in meters. So square meter will be the unit. Clear? So we have applied the formula of total surface area of the cylinder. Right? So this is how we are going to do the questions also asked later on. Now, if you see, they're asking, note that lateral surface area of a cylinder is the circumference of base and height of the cylinder. Yes, it is same because it is 2 pi rh. 2 pi r is the circumference of base and height is of the base, and h is the height. Now it is giving us the curved surface or total lateral surface area of the cylinder. Can we write lateral surface area of cuboid as perimeter of base? So perimeter of base, just see, the base will be rectangular. It will be having L and B. L and B. So what is the perimeter? 2 into L plus B into my height. Into height. So it will give us 2L plus 2B and it is H. So we get 2LH plus 2BH. Right? So is it giving us the lateral surface area of the cuboid? Lateral surface area of the cuboid is 2 height L plus B, and that is 2LH plus 2BH. Are we getting that? Yes. So yes, if we multiply the perimeter of the base of cuboid and the height, it gives us what? It gives us the lateral surface area. Yes, it gives us. Okay. Now in the next part, there is a question. They are asking, an aquarium is in the form of a cuboid whose external measures are 80 centimeter, 30 centimeter and 40 centimeter. That means we are given the length 80, the breadth as 30 and the height as 40 centimeter. The base, side faces and back face are to be covered with a colored paper. Right? So what does it mean? Which faces are to be covered? So suppose we have, it is in the shape of a cuboid. So if I have this cuboid, let us just draw a rough cuboid. Okay, like this it is there. Now in this, what are they saying? They are saying the base, that means this. Okay, the side faces, that means 1 2 3 side faces are these only. Let us name them. One is this one, the side face, this side left and right, right, and this is the base. Now the back face is this one. Obviously, when it is an aquarium, the front is not to be covered, right? We can't cover the front because we need to see the fishes, right? That portion will remain as not covered. So these are the faces, that means 2 side faces, 1 back face and 1 is the base one, that means the bottom one. They are to be covered with the colored paper. We have to find the area of the paper needed. Area of the paper needed will be the area of all of these. So if we calculate, just the length is 80, the breadth is given as 30 and height is given as 40. This is the measurement. Now if we find it out for the base, so area of base, what will be the area of base? 80 into 40 Will it be 40 or it will be 30? It will be 30. Why? Because 40 is the height. For the base, it is length into breadth, that is 80 into 30. So 8 3s are 2400 square centimeter. We have the area of the base. Now, let us find out area of the side. So we will just multiply it with 2. So area of side faces. How many side faces do we have? 2. So 2 into side faces area will be how much? 30 into 40. Length into breadth. So just see 2 3s are 6. 6 4s are 24. Right? So 2400 square centimeter is the area of its side faces. Now area of back face we will calculate. In the back face, because it is a rectangle, we know this is 80 and the standing one is 40. So when we calculate the area, it will be 80 into 40. 8 4s are 32. 3200 square centimeter is the area of this. Is that clear? Now we have to find out the total paper required. So area of colored paper, right, it will be 2400 plus 2400 plus 3200. So 2400 is 4800. In that we have to add 3200. So we get 8 into 10, 4 and 3, 7 and 1, 8. 8000. What is the answer? 8000 square centimeter. This is the area of the paper needed. Is that clear? So we calculated the area of base. They are saying that the base, then the side faces are the left hand side faces, and the back face. The front and top are not to be covered. Okay, and from the top, it's an aquarium, it will be opened, right? Okay, so what we have done, we have added the areas, and that will be the area of the paper required to cover this aquarium, right? Now, here is another question. It says, so now we have done this. Okay, here is another question. It says the internal measures of a cuboidal room are 12 meter, 8 meter and 4 meter. We have to find the total cost of whitewashing all the 4 walls of the room, right? Suppose you have to just whitewash the 4 walls. So area of 4 walls. Area of 4 walls, what is the formula? 2 into h into L plus b. So 2 into h is how much? Here 4 and L is 12, b is 8 square meter. So 2 into 4 into 12, 12 plus 8 is 20 square meter. So 2 4s are 8, 8 2s are 16, 160 square meter we get. Right? So what we have done, area of 4 walls we have calculated. How? By applying the formula. H is 4, L is 12, B is 8. Adding them, 2 into height is 4, so 4 is written here. 12 plus 8 is 20. So 20 into 2 is 40, 40 into 4 is 160 square meter. Okay, now cost of whitewashing per square meter, that means 1 square meter is rupees 5. So cost of whitewashing, how much? We have 160 square meter is rupees 5 into 160. How much will we get? Rupees 0. Just see, 5 6 are 30, carry is 3, 5 1s are 5 and 3 8. So rupees 800 will be spent on it. Now they are saying that what will be the cost of whitewashing if the ceiling of the room is also whitewashed? Now if the ceiling is whitewashed, what will be the area of ceiling? It will have, if you see, the ceiling will have length and breadth, right? So it will be length into breadth. The length is 12 meter and the breadth is 8 meter, that is 96 square meter. And cost of whitewashing 96 square meter is equal to 96 into rupees 5, because we are going to multiply. So we will get rupees 5 6 are 30, 3 is the carry, 5 9s are 45, right? 49, just see here, 96 into 5, 5 6 are 30, 3 is the carry that we take, 5 9s are 45. 45 plus 3 is 48. So 480. These are the rupees. Now if the ceiling and all the four walls are whitewashed, then the total cost is 800 plus 480. Right? That becomes 1280. That would be the total cost if they ask. Just for ceiling it is rupees 480, and for all the four walls it is rupees 800. Got it? Okay. Now we will move to the next question. Here if you see, they're saying there is a building, and in that building there are 24 cylindrical pillars. Cylindrical pillars means the pillars are in the form of cylinder. The radius of each pillar is 28. What is the radius given? 28 centimeter, and the height is given as 4 meter. So centimeter and meter, convert this also into centimeter or convert into meters. So just see, 400 meter. So in centimeter it will be just the cost is given as per square meter. So we will convert 28 also in meters. So how will we do that? We will divide 28 by 100 and it will be converted into meters. 0.28 meter. This is the radius and this is the height. Now they are saying how many pillars? 24. Right? So find the total cost of painting the curved surface area of all the pillars at the rate of rupees 8 per square meter. That means we have to find the curved surface area of 24 pillars. So if we find out area of one cylindrical pillar, or it is to be mentioned that it is curved surface area. So curved surface area of one cylindrical pillar. What is the curved surface area formula? 2 pi RH. So 2 into pi is 22 upon 7. I told you whenever it is not mentioned, we have to take it as 22 upon 7. R is given as 0.28 and height is 4 meters. So square meter will be the unit of it. Clear? Now we are going to solve it. So just do the calculations. 2 into 22, we get it as 44. So do the calculations in your notebook. What are we going to get? We will get 2 into 22 into 0.28 into 4, and we have to divide this by 7. So we get the answer after solving as 7.04 square meter. Now it is for one cylindrical pillar, right? CSA of, that means curved surface area of 24 pillars. What will be the area of that? 24 into 7.04 square meter, right? 7.04 square meter. So we will multiply this 7.04 with, okay, so we are going to multiply it with 24. So multiplying it with 24, we get 168.96 square meter. So this is the curved surface area of 24 pillars. Now we know for 1 square meter, right, cost of painting is rupees 8. So for 168.96 square meter, cost of painting would be rupees 8 into 168.96. Right? So we are going to multiply this with how much? Rupees 8, because rupees 8 is the cost for 1 square meter. So when we multiply it with 8, we get 1351.68. Right? These are the rupees that will be spent on the painting of 24 pillars. Okay, I hope this is clear. Now moving on to the next one. Okay. In this question, it is said we have to find the height of the cylinder. What is to be calculated? Height. The radius is given to us as 7 centimeter and the total surface area is given as 968 square centimeter. So units are same, no need to change. We know total surface area is given as 968. What is the formula for total surface area of the cylinder? It is 2 pi r into r plus h. Do remember the formula? Okay, so 968 we got. Now 2 into 22 upon 7 into radius is 7, 7 plus h is equal to 968. So 7 and 7 got cancelled. We got 44 into 7 plus h is equal to 968. So this implies that 7 plus h is equal to 968 upon 44. Right, so now we are going to solve it. Just see, can we cancel it with 11? Yes, 11 fours are 44. Here we will write 11 8s are 88, and we are left with again 8. So 11 8s are 88, 4 1s are 4 2s are 4 2s are 8. So we are left with 22, and then we will solve it as 7 plus h. We got 22, so h will be equal to 22 minus 7. Right, so 22 minus 7, how much are we left with? 15. 15 centimeter is the height of that cylinder whose radius is 7 centimeter and the total surface area is 968 square centimeter. So this is how we have calculated. Now I have given you a little practice of some questions. That means I have given you ideas of how the question can be, and we have discussed the total surface area, the curved surface area of three solid shapes: cube, cuboid and cylinder. Right, so this way we are going to apply this now in these formulas. And thank you so much. Have a great day.